Today, electrochemistry part 5. Electrochemistry part 5. This is the continuation part. Okay. So, the last class we have discussed resistance, resistivity, conductance and what? Conductivity. So, today I am discussing molar conductivity. Today I am discussing molar conductivity. What is this molar conductivity? Yes, this molar conductivity is denoted by lambda m. It is denoted by lambda m. What is this molar conductivity? Molar conductivity is defined as it is a conductance of what? Conductance of what? All ions. Conductance of what? All ions produced from what? Produced from 1 mole of what? 1 mole of what? Electrolyte. 1 mole of what? Electrolyte. So this is the definition of what? Molar conductivity. Only conductivity is what? Only conductivity is reciprocal of what? Resistivity. But here the molar conductivity. Molar conductivity is defined as the conductance of all ions produced from 1 mole of electrolyte. So it is called molar conductivity. The next is here, and this molar conductivity is related to what? This molar conductivity is related to conductivity. It is related to what? Conductivity. This molar conductivity is related to conductivity. How it is? This is the molar conductivity is equals to conductivity divided by what? C. Molar conductivity is equals to conductivity divided by C. But here the conductivity, it is kappa. We can read as kappa. It is a, what is the unit? It is a Simon per meter. It is a Simon per meter. And the concentration is nothing but a mole per meter cube. This is a mole per meter cube. Is it correct? Yes. So here 1 mole per meter cube. 1 mole per meter cube is equals to 1000 liter per meter cube. Okay, 1000. And the concentration is nothing but a molarity. This is what? Molarity. It is nothing but a mole per liter. This is nothing but a mole per liter. And how to put an equation 1, so we can get what? The unit of molar conductivity. So this is molar conductivity is equals to what is this conductivity? So this is conductivity is what? Simon per meter. This is what only Simon per meter. Yes. What is the concentration? Concentration is mole per meter cube. 1 mole per meter cube is equal to 1000. This is nothing but a 1000 liter meter cube. And this is what is the concentration? The concentration is nothing but a mole per liter. So here what happens here? Now it is, so per meter cube comes to numerator, it is meter cube, and it meter cube minus per meter, so we can get what? What is the unit? Simon meter square per mole. Simon meter square per mole. This is the unit of what? This is the unit of what? Molar conductivity. Or what is the expression for molar conductivity? Molar conductivity is equals to, this is what I mean. So this is called what? Molar conductivity. And this is that whole, it is what? Concentration. The concentration is what? 1000 liter per meter cube, mole per liter. So here we can get the unit of molar conductivity is what? The Simon meter square per mole. And now what is the expression? The expression, this is what? Conductivity divided by what? 1000 into what? 1000 into what? C. So this is the, it is the expression for what? The molar conductivity, or it is the relation between molar conductivity and the conductivity if the unit of conductivity is what? Simon per meter. Similarly, suppose if it is a, for example, it is O. Suppose the same molar conductivity is in terms of what? Suppose in terms of what? Here, now the conductivity is in terms of what? Simon per meter is what? Suppose if the unit of conductivity is Simon per centimeter and the concentration is nothing but a mole per centimeter cube, but here so we can write, so molar conductivity is equals to, so what is the conductivity? Conductivity is what? Simon per centimeter, and it is nothing but a 1000 cm cube divided by what? Liter, divided by what? And it is divided by what? Mole per liter. So we can write here, this is what? Mole per liter. So here what is the unit? It is what? This is what? Centi per centimeter and centimeter cube. It is nothing but Simon centimeter square. This is what? Per mole. So this is the unit of what? Molar conductivity. If conductivity is in terms of what? Simon per centimeter. So this is the molar conductivity. Okay, the next is what here? The next I can discuss what? The variation of what? Conductivity and what? Molar conductivity. Now I can discuss what? The variation of what? Conductivity and, yes, this is a very important concept. Variation of what? Variation of what? Conductivity. Variation of what? Conductivity and what? Conductivity and molar conductivity. Conductivity and what? Molar conductivity. Yes, you know that. Already we know that. What is this conductivity? What is the conductivity? Conductivity is a reciprocal of what? Resistivity. And we know that. What is the molar conductivity? Molar conductivity is nothing but the conductance of all ions produced from 1 mole of electrolyte. Okay. So the variation of conductivity and molar conductivity. Here conductivity and what here? The conductivity and molar conductivity. Conductivity and what? Molar conductivity changes with what? Changes with what? Concentration of what? Electrolyte. Changes with what? Concentration of what? Electrolyte. Changes with concentration of what? Electrolyte. So here what is the important concept is that both conductivity and the molar conductivity, it changes with what? Change in concentration of electrolyte. For example, I can discuss here conductivity. Now I can discuss, first is the conductivity. So this is the conductivity. Conductivity is always, the conductivity is always decreases. Conductivity is always decreases with decrease in concentration. Decrease in concentration. Decrease in concentration of what? The conductivity is always decrease with decrease in concentration of both strong and weak electrolyte. Both strong and weak electrolytes on dilution. Weak electrolyte on dilution. Upon dilution, so what happens? The concentration is decreases. When the concentration decreases, the conductivity is also decreases. The conductivity is always decreases with decrease in concentration of both strong and weak electrolyte. Both strong and weak electrolyte on dilution. On dilution, what happens? So the concentration is decreases. Simultaneously, even the conductivity is also decreases. Why it is conductivity decreases? It can be explained. It can be explained. It is explained, or this is because it is explained, or this is because the number of ions per unit volume, the number of ions per unit volume carry current. What do you say? It is explained. This is because of the number of ions per unit volume carry current is decreases with water, decreases with dilution. Okay, so this is the because the number of ions per unit volume that carry current decreases on dilution. So this is the reason. So now what is the conductivity? What is the conductivity? How can you define this conductivity? Yes, I can. What is this conductivity? Okay, what is this conductivity? the conductivity of a solution, conductivity of what solution, conductivity of a solution at a given concentration, at any given concentration, at any given concentration, at any given concentration is the conductance of what? Is conductance of what? 1 unit of what? 1 unit volume. It is conductance of what? 1 unit volume of electrolytes. 1 unit volume of electrolyte placed between electrodes of what? Electrodes of what? Electrodes of what? Area of unit area section. Electrodes of unit area of section. Unit area of what? Cross section. Unit area of what? Cross section. And also distance of what? Distance of what? 1 unit length. The distance of what? 1 unit length. So this is the definition of what? Definition of what? Conductivity. So why the conductivity decreases? This is because the number of ions per unit volume that carry current is decreases on dilution. So this is the conductivity. And how can you define this conductivity? Conductivity of a solution at a given concentration is the conductance of 1 unit volume of electrolyte is placed between what? 2 electrodes of what? Unit area of cross section and the distance of what? 1 unit length. You know that the conductance is equals to conductivity divided what? L by A. Suppose if L is equals to what here? Okay, what is the conductivity? Sorry, what is the conductivity? So this is what conductivity is equals to. So conductivity is equals to what, anybody? So here conductivity is equals to what? Conductance. Conductance is equals to conductivity and what? A by L. Suppose if length is what? 1 and area of cross section is 1. So here conductance is equals to what? Conductance is equals to what? Conductivity, length of what? 1 unit and area of cross section is what? Also 1 unit. So this is the decrease in what? Conductivity. You know that already. Conductivity is decreases on dilution. Now here molar conductivity. So the molar conductivity, first is what is molar conductivity? Already we know that the definition molar conductivity is the conductance of all ions produced from 1 mole of electrolyte. Here molar conductivity is nothing but a conductance of what? Conductance of what? Conductance of what? 1 mole of what? Conductance of what? V volume of solution. V volume of what? Solution containing 1 mole of electrolyte. 1 mole of what? Electrolyte. 1 mole of electrolyte is placed between 2 electrodes of area of cross section of electrodes of area of cross section is what? Cross section is unit area of cross section and distance of what? Distance of what? Distance of 1 unit length of distance of what? Unit length. So it is called what? Molar conductivity. Molar conductivity is the conductance of what? Conductance of what? V volume of solution containing 1 mole of electrolyte is placed between 2 electrodes of unit area of cross section and the distance of what? Of unit length. We know that what is this molar. So this is what molar conductivity is equals to. Molar conductivity is equals to what, anybody? So molar conductivity. Yes, here I can write molar conductivity. I can write here. So this is nothing but a conductivity. This is what? A by L. Here L is equals to what? 1. So here A is nothing but a V volume of solution. So molar conductivity is equals to conductivity. So it is nothing but a. So here what happens? So here the molar conductivity increases. Molar conductivity increases. Molar conductivity increases. Okay, the molar conductivity is increases with decrease in concentration of what? Electrolyte on dilution. But conductivity is decreases on dilution, but the molar conductivity is increases with decrease in concentration of electrolyte on dilution. This is because what is the reason? This is because the V volume of what? The solution of what? V volume contain what? 1 mole of electrolyte. 1 mole of what? 1 mole of what? Concentration of what? Electrolyte increases. So here what happens here? So molar conductivity increases, whereas conductivity decreases. Molar conductivity increases with decrease in concentration of electrolyte on dilution. This is because the volume V of solution contains what? The concentration of what? Electrolyte is increases. So finally what we have found that the conductivity decreases is more than compensated by what? The increase in volume. So what we have found that? The decrease in conductivity. The decrease in conductivity is more than compensated by what? Increase in volume. So this is called what? Molar conductivity. In the examination, the very important question, what is molar conductivity? Molar conductivity is defined as the conductance of all ions produced from 1 mole of electrolyte at a given concentration. It is also correct. Otherwise, what is the molar conductivity? Molar conductivity is the conductance of what? The V volume of solution containing 1 mole of electrolyte is placed in between the 2 electrodes of what? A unit area of cross section and the distance of 1 unit length. And in the examination, one more question, give the relation between conductivity and molar conductivity. So this is what K. So K is nothing but, so it is kappa is conductivity. It is also the relation between what? Molar conductivity and conductivity. Yes. So here now I can discuss. So already you know that the conductivity and molar conductivity. So now I can discuss one by one for strong electrolytes. Sorry, before going to the strong electrolyte, first I can discuss when concentration approaches to what? 0. When concentration approaches to 0, molar conductivity is known as limiting molar conductivity. And is denoted by symbol. Lambda naught of m. Lambda m is molar conductivity. When concentration approaches to what? 0, the molar conductivity is known as limiting molar conductivity. So now here for strong electrolyte, okay. For strong electrolyte, the molar conductance increases slowly on dilution. For strong electrolyte, molar conductance lambda m increases slowly on dilution, and it can be represented by what? By equation lambda m is equals to lambda naught of m minus of what? C or square root of what C. So this is called what? Debye-Hückel-Onsager equation. It is called Debye-Hückel-Onsager equation. Suppose when concentration tends to what? 0. When concentration tends to 0, the molar conductance is equals to limiting molar conductance. This is called lambda naught m is called limiting molar conductance. Lambda m is called what? Molar conductance when concentration approaches to 0. And the increase in what? The molar conductance is explained by using what graph? Lambda naught m against what? Square root of what? C. So we can get what? We can get what? A straight line. We can get what? A straight line. So this intercept, it gives this intercept, it gives what? Limiting molar conductivity, and the slope is nothing but a minus a. It depends on what? It depends on what type of electrolyte. Okay, this is for strong electrolyte. Next is for weak electrolyte. Strong electrolyte is over. What is for weak electrolyte? I can discuss here. Weak electrolyte. So what is this weak electrolyte? So what is this weak electrolyte? Yes. So weak electrolytes, the ionizes partially. Okay. So weak electrolyte like acetic acid. Weak electrolyte like acetic acid. Why? Acetic acid, it ionizes what? Partially. So weak electrolyte like acetic acid have lower degree of what? Lower degree of what? Ionization. Lower degree of what? Ionization, or lower degree of what? Dissociation. Lower degree of what? Dissociation. Lower degree of what? Dissociation at a higher concentration. At a higher concentration. At a higher concentration of electrolyte. Okay, at higher concentration of electrolyte. So this is for weak electrolyte, they ionizes partially. Because of this reason, the weak electrolyte like acetic acid have lower degree of dissociation. What is the degree of dissociation? Alpha is nothing but a degree of dissociation, and dissociation at a higher they have no degree of dissociation because of what? A higher concentration of what? Because of what? Higher concentration of what? Electrolyte. So here next the increase in molar conductance or change in molar conductance of weak the increase in molar conductance on dilution due to what? Due to what, anybody? Number of what? Due to what? Number of what? Ions. Number of what? Ions, or degree of what? Due to what? See here, the concentration of electrolyte. The increase in delta M on dilution is due to what? Due to dissociation of what? Due to dissociation of what? Dissociation of what? Ions at a lower concentration. At a lower concentration. At a lower concentration. But so here the limiting, when concentration approaches to what? 0. When concentration approaches to 0 and the alpha is equals to what? 1. The limiting molar conductivity is equal to 1. So at low concentration and at low concentration of what? Electrolyte. So we can't measure what? We cannot measure molar conductance accurately. Here what happens? The weak electrolyte like acetic acid, they have low degree of dissociation, and because of higher concentration of electrolyte. And increase in molar conductance on dilution is due to what? Dissociation of what? Ions. On dilution, the concentration is what? Decreases. When concentration tends to what? 0, it is called what? Limiting molar conductivity. and alpha equal to 1. So and at low concentration of electrolyte, so we can't measure what lambda m accurately. So it can be measured by using what? Kohlrausch's law. By using what? Kohlrausch's law. By using what, anybody? Kohlrausch's law. Okay. By using Kohlrausch's law. Okay. At any concentration C, that the degree of dissociation is the ratio of molar conductance at a given concentration to limiting molar conductivity. So for weak electrolyte, so what is the dissociation constant? Dissociation constant K is equals to C alpha square minus of what? 1 minus of alpha, and how to put the alpha value in this equation. So we can get nothing but lambda of what? M square. Next is what, anybody? C of lambda square. Next is what, anybody? Lambda naught of M, and this is the lambda naught of M minus of what? Lambda M. So this is for what? This is for weak electrolyte. For weak electrolyte, so they dissociate partially and they have low degree of dissociation. So at an infinite dilution or when concentration approaches to 0, so we can't measure the accurate delta M value at a lower concentration. So because of this reason, so we can get the lambda M value accurately by using what? Kohlrausch's law at any concentration. So degree of dissociation is equals to lambda M at a given concentration to the limiting molar conductivity. Kohlrausch's law. What is this Kohlrausch's law? You know that the limiting molar conductivity. What is the meaning of limiting molar conductivity? When the concentration tends to 0, so lambda naught M is called what? Limiting molar conductivity. Limiting molar conductivity of an electrolyte. Limiting molar conductivity of an electrolyte is sum of individual contribution of what? Of anion and what? Cation. Anion and what? Cation is called what? Kohlrausch's law. What is in the examination 1 mark question? Already it is repeated. What is the Kohlrausch's law? Limiting molar conductivity of an electrolyte is the sum of the individual contribution of what? Anion and cation. For example, the molar conductance of what? NaCl. Molar conductance of NaCl is equals to what? The ionic conductance of what? The limiting conductivity of what? Na plus, and the limiting the conductivity of Cl minus. So this is the expression for what? Kohlrausch's law. Kohlrausch's law is nothing but the sum of the individual contribution of what? Anion and cation. So it is called what? Kohlrausch's law. The problems is based on conductivity is equals to G into G star. So this is conductivity. G is what? Conductance. G star is called cell constant. What is the cell constant? G star is equals to L by A. And one more expression is rho. Rho is called what? Resistivity. Resistivity is equals to Ra divided by L. And next molar conductance is equals to conductivity into 1000 divided by C. These are the problems based on what? These formulas. First problem. The conductivity of 0.02 M KCl solution at 298 Kelvin is 0.0248. 0.08. This is Simon per meter. Calculate its molar conductivity. Calculate its molar conductivity. So this is the expression. So here, Simon per centimeter. Okay, Simon per centimeter. Okay. Now I can suppose the two equations are there. Suppose if K is, the conductivity is Simon per centimeter, use this expression. Suppose if conductivity is in Simon per meter, so how to use this expression? Conductivity divided by 1000 into C. Here the conductivity is in terms of what? Simon per centimeter. Simon per centimeter means what? You have to use this expression. Molar conductivity is equals to conductivity into 1000 divided by what? C. Yes, now I can take expression. Molar conductivity is equals to conductivity into what? 1000 divided by C. Now the solution. What is the C? C is nothing but a concentration. The concentration is given 0.20. What is the conductivity? The conductivity is nothing 0.0248 Simon per centimeter. So what you have to calculate? You have to calculate what? Molar conductivity. So molar conductivity is equals to 0.0248 into what? 1000 divided by what? What is the concentration? Concentration is 0.20, so we can get, so you have to multiply 0.024 into 1000 divided by 0.20, so we can get what? 124 Simon centimeter square per mole. So this is very important example for annual examination point of view. Okay, please take down this.